Impulse and momentum are the third type of ways to work kinetics problems. Now, impulse is a measure of force over a time period hitting an object. And then momentum is the change, momentum is the velocity times the mass of the object. So change in momentum is the mass times that change in velocity. So we get this if we integrate Newton's second law equation. Sum of the forces is mass times acceleration. So A and F are vectors. We integrate this in an inertial reference frame. That's how we find the impulse and the momentum. So that equals m dv dt. So then we rearrange. Sum of F dt equals m dv. So then integrate over T1 to T2, V1 to V2. So this is impulse and momentum. So this is just kind of reformulating Newton's second law, but we're putting it in terms of velocities instead of acceleration. Now, if the force is constant over a time period, we know in general the mass is constant. So then when we integrate this, we get F times T2 minus T1 equals M times V2 minus V1, which we also write as F delta T equals M delta V. So basically, if the object gets hit by force over a time period, its velocity changes. That's what this law is telling us. So another way to rearrange, we know if an object is moving and it gets hit, then it will have a new velocity. So if we know the force and the time, one of the velocities, we can figure out the other velocity. So we know if we know how fast something is moving and how long it's hit for, we can figure out how fast it's going to be moving after that. So this is momentum, and this is linear momentum as opposed to angular, because it is translational. So we know that momentum is mass times velocity. Then for two things going at the same speed, the bigger one will have more momentum. And for two things that are the same size, the faster one will have more momentum. So if m is constant and v goes up, momentum increases. If v is constant and m goes up, momentum increases.